All right, let's take a look at significant figures and calculations. First step, counting significant figures. You have to recognize that non-zero numbers are always significant. So whenever you're doing this, anytime you see a 7, a 2, a 3, a 5, a 6, an 8, any non-zero numbers always count as significant figures. What you got to worry about are the zeros, and there are three types. We have captive, we have leading, and we have trailing. Captives always count. Leading never count. And trailing are conditional. They count with a decimal point. If there's no decimal point in the number, they don't count. So let's take a look at it. We'll see some examples of all three types in here. It's best to learn them on the go than just to try to show you other examples. 7, 2, 3, 5, non-zero numbers. Non-zero numbers count. These zeros are leading. They're leading because they're the first thing in the number. They come before the first non-zero number. They all come in front of the 7. And leading zeros never count. So we would say this number has 4 significant figures. Move on to the next. 7, 8, 3. Non-zero numbers always count. These zeros are trailing. And again, trailing counts as long as you got a decimal point. We have a decimal point. They count. That number has 5 significant figures. Let's move on to the third. The 7 and the 3, they count. They're non-zero numbers. This 0 is a captive. It comes between two non-zero numbers. Think of them as being surrounded by significant figures. They always count. You can't jump around with significance. If 7 is significant and 3 is significant, the 0 in between has to be significant too. These are trailing. Trailing come at the end of the number. They come after the last non-zero number. They're significant if you have a decimal point. We have a decimal point. They count. This number has 5 significant figures. Finally, 8 and the 7 count. They're non-zero numbers. These are trailing zeros because they come at the end of the number. They come after the 7. They come after the last non-zero number. That's what makes them trailing. They're only significant if you have a decimal point. There is no decimal point in this number, so there are only 2 significant figures there. Remember, leading and trailing have nothing to do with where the 0 is relative to a decimal point. They are where the zeros are relative to either the first or the last non-zero number. Leading come in front of the first non-zero number. In this case, all 4 are leading because they come in front of the 7. Trailing come after the last non-zero number. So those 2 are trailing zeros not because they're after a decimal point, but because they're after the 3. These are trailing zeros because they come after the 7. Has nothing to do with the decimal point. Again, it's after the last non-zero number. Moving on to rounding. When you round to a certain number of significant figures, you have to identify your significant place values first. What you're doing is you're counting from left to right, starting with the first non-zero number you get to. So in this first one, I can start right at the very beginning because it starts with a non-zero number. That'll be my first significant place value. That'll be my second one. The 8 will be my third one. So my cutoff is right after the 8. It's followed by a 7, so I will round this up to a 9. The 7, the 0, the 9, the 6, those are all after the decimal point. Those get dropped. And we write it down as 36.9. Now notice, when I rounded that, I didn't start at the end of the number and work my way forward like they do in math classes. We recognize the further you get from the rounding point, the worse the numbers get, the more uncertainty they have. So we ignore those numbers. and we only look at the place value immediately following the number we're rounding. Let's take a look at the next one. Again, when we find our three significant place values, we have to start with the first non-zero number. So we don't start here. This is the first one, the 5. The 8 is the second one, the 7 is the third one. The cutoff is after the 7. These zeros are not significant because they're leading. We ignore them. 7's followed by a 0, so we leave it alone. We drop everything after the decimal point we don't need. 0.000587 is the rounded answer. Again, we didn't start at the end and work our way forward. We only looked at what's immediately following. Finally, this one. We can start at the beginning again because we start with a non-zero number. 1, 2, 3. Cutoff is there. The 9 is followed by a 6. It does not round up to 0, it rounds up to 10. So that changes to a 0. The 8 changes to a 9 because the 1 from the 10 carries over. This is all in front of a decimal point, so we don't just drop it. We replace them with insignificant zeros. If we don't replace them, then the 2 drops from the 100,000s place all the way down to the hundreds place. You can't have that happen. That's like borrowing $200,000 from somebody, paying them back 200 and saying everything's even. It's not going to fly. It doesn't fly there. It doesn't fly in science either. We got to keep those place values so those insignificant zeros are required. Interesting problem though when we write this down. There are only 2 significant figures there. We need to have 3 significant figures. Now, if you know scientific notation, you can put it in scientific notation and take care of that pretty easily. But until we talk about scientific notation, what we're going to do is put a bar over the last significant zero. What that bar means is count everything up to me, ignore everything after me. So we can count this 0 as significant, we ignore those 3 as being insignificant. One more thing, if we had the number 52 and we had to round that to 3 significant figures, and most of the time we round it's because the calculator gives us too much stuff. But sometimes the calculator does not give us enough information and we have to add to it. To add another significant figure to the number 52, we'd simply throw a 0.0 on the end. It's a trailing 0, it's got a decimal point, it counts. It doesn't change the numerical value, so it's still good in all the calculations, it just adds more significance to it. Let's get to the multiplication, subtraction, addition, all the fun stuff, the calculations that we do. When you add or subtract, it's all about place value. When you multiply and divide, it's all about significant figures. Our limiting factor is the number that determines where we round. In addition and subtraction, the simplified rule that we're using is the limiting factor is the number with the fewest place values after the decimal point. This has 1 number after the decimal point. This has 3 numbers after the decimal point. This has 1 number after the decimal point. We can consider both of these to be our limiting factors. They have 1 number after the decimal point, so the answer has 1 number after the decimal point. So 3.57 plus 4.580 plus 0.2 gives us a calculator answer of 40.48. Again, we're limited to 1 number after the decimal point, so we cut off after that 4. 8 rounds this up. 8 gets dropped. 40.5 is how we would record that answer. Again, recognizing that we don't really know that 8 for sure. In multiplication division, limiting factor is the number with the fewest significant figures. This has 3 significant figures. This has 2 significant figures because the leading zeros don't count. That is the limiting factor. It has 2 significant figures, so our answer can only have 2 significant figures. We punch it in a calculator, gives us an answer of 7.224. Again, for our significant figures, start over here, find the first non-zero number. That's our first one. That's our second one. there's our cutoff. The 2 is followed by a 2, so we just leave the 2 alone, drop everything after the decimal point. 7.2 is how we would record that answer. I am aware that there are some that teach about these 4s and rounding things down when you see 4s. We are using the basic rules for math rounding when we do our rounding with significant figures. Make sure that if you're one of my students, that's what you do.